Ovaj ovdje meetup je prvi meetup koji organizujemo. I ideja je da, kao što i piše tamo, znači da podijelimo iskustva, podijelimo neke probleme, nešto naučimo jedno drugih, upoznamo se. I eto, danas će prvi govornik biti Caslav, postavio sam ja.
Da, u budućnosti planiramo neka malo jače i da kažem veće možda predavanja potencijalno stranaca, ne kažem da ovo nije veliko predavanje, ali ovo je prvo, da ćemo ga tako pamtiti, a to su i neki ljudi možda iz AWS-a, također i ideje da dođe iz Ogurija, team lead iz Pariza, iz Francuske, koji će pričati malo više o nekoj Kubernetes strani, a bit će i Terraform predavanja dalje, tako da svakako je cilj da budemo što aktivniji i da posle ovog nekog perioda gdje baš nismo bili aktivni zbog cijele korone i to, što više šerujemo znanje i da vidimo što se desilo među vremenu i da zajedno napredujemo. Tako da, za sva pitanja smo tu, ja sad ne znam šta bih drugo dodala, tako?
Puno. Dobrodošli ljudi.
Dobrodošli.
Eto i možemo da
My name is Caslav, as you already know. I've been behind the keyboard for the better part of my life, basically more than I would care to admit. Now I have a question first. How many of you here have already used NIX in professional capacity in production or had any experience with it in a production environment? Okay, that's good so far because we profiled the introduction session just to give a brief overview so it won't be very technical in that sense. How many of you use NIX in any home capacity? Okay, that will be interesting. I'll try to explain then what it is in this session so I'm guessing that it's well profiled then in that sense. So this is NIX at a glance. This is just a short overview of functional package management system. Now, what I found out while learning NIX is that there is a lot of people involved when you're actually learning something as complex as NIX. It has a steep learning curve. So I have to mention some of the people I worked with that actually helped me to understand the concepts and get to the parts where I can actually use it in production. So the list is rather long. It's Elko, Samuel, Rock, Tim, Jonathan, John, Michael, and of course NIX builds. Because in this demo here, some of the concepts and ideas were taken heavily from the NIX builds and from documentation, configuration manuals, NIX conference, and so on. Without further ado, what is NIX? First of all, it's a very inconvenient search term, meaning if you search for NIX, you'll find a trove of things that aren't NIX. First of all, it's used as a general asterisk in search terms, so anything Unix or Linux related will pop up as a first hit. There is a number of language and linguistic references that will also come handy in clouding the search technology here. So when we search on the net anything related to the NIX, we have to be very specific. NIX is covering four rather broad topics. First of all, NIX is programming language. Next, it's package manager. It's also operating system and deployment tool. Now, when we search for some of those terms, in order to get proper hits, we should augment the NIX with the proper part we are interested with. So, NIX package manager, NIX a special language, NixOs, and so on. So, searching just for NIX would be very confusing. Why NIX? I mean, we already do have a lot of things that we can search on the internet that will result in ambiguous search results and so on. So why we do need NIX specifically? What are we trying to solve with NIX? Reproducible builds. Now, this is a holy grail of any CI/CD pipeline. We want to have reproducible builds, deterministic. So when we define something that we want to redeploy after several months, we want to make sure that these builds are, again, to the byte exactly the same as they were when we first time deployed. Now, as you already know, there is a number of things that will go against this principle. There's literally tons of things that interfere with the reproducibility of the build. Now, apart from just having it reproducible, we also want to make sure that nothing downstream, when we are having the chain of the build toolchain, that something wasn't changed without our knowledge, so that the end result will always be the same, even if something in between is changed that wasn't our jurisdiction to monitor or to handle. That's why we usually pin everything. This concept is also borrowed from other programming languages and so on, so we pin literally everything, sources, compilers, script dependencies, libraries, whatever we are pinning them, so we are absolutely sure that next time we're deploying exactly the same thing. Now, this is basically resolving dependency hell. On the picture below, that's Mozilla's runtime dependency graph. So it's kind of easy to understand and grasp and also handle. So this type of dependencies is what NIX is basically excelling at and good at, solving those type of issues without us worrying next time we get different result than first time. Now, short history of NIX. There is a different beginning and very interesting one. So far in my experience, most of the technologies emerging from the industry side. Like there is some need, some type of the business need to solve immediately, and then some aspect of this need is usually generated and then automated in some fashion. So you're getting tools that are good at certain problem domain that they're resolving. And then computer science is usually following, trying to create a big picture out of those pieces. And then basically computer science is lagging behind the technology advancement is done in the other industry fields that IT is used at. Now here's the other way around. NIX comes from computer science. So this is totally different than the usual way of introducing technologies to the industry standards. Elko Dostra, he started NIX as a research project in 2003. It was his PhD thesis, and in 2006 he basically finalized his PhD thesis and laid out the foundation for formalization of NIX language. On the side here we have a picture of the document that he was submitting, so this is basically the title of his PhD. And he was trying to do functional software deployment model. That was the problem he was trying to resolve at that point. In the meantime, from 2003, basically 2004 when the first beta version of components, up to today, NIX was very heavily invested in research and development. Some quite interesting workarounds and some quite interesting forks of the current way of handling NIX were made. So if you're looking at the documentation, you also have to be very careful at which period you're looking at, because the documentation is always lagging behind the advancement in the NIX. So if you're not actively involved in the community of the NIX developers and NIX practitioners, you will have sometimes hard time distinguishing which commands are now obsolete, why they're replaced with something else. And also there is some mix-up in some regions when the technology is being changed a little bit. So sometimes it's a little bit hard to read and understand the code based on the examples you can find on documentation on the net. So that is something to keep in mind. Generally, when we talk about NIX releasing, we're talking about two things mainly. First is package manager as such, and second is NixOs. Package manager is doing what it says, and operating system is based on the NIX package manager. So current version is 2.7.0. This is a stable one. 2.8 is in pre-release phase at the moment, and 21.11 is current NixOs stable version. Again, it's usually twice a year release cycle, but it again depends on the multiple factors. It's very actively being developed and improved. There is large community, there is a Discord group and so on. For example, one of the terms I just want you to mention, but I won't go into the details. I will just mention it several times during the presentation. NIX Flakes is introduced in request for comment number 19 in 2019, and current request for comment is 102, just to have the scope of the changes that are being made there. It's also reaching to the production maturity, meaning that it's already being used actively in the production setups very heavily and without much of the issues that we would expect of operating system that is being developed in this capacity. And I think it's coming to a crucial and very interesting point in its history, similar to when Docker, as the Dockerization as a concept, was slowly seeping into the industry. We are coming to the point where most probably NIX, because it's solving very hard problems in a very elegant way, it will simply take its rightful place in the same manner that some other technologies were taking their place along the way. So if you're an early adopter of the NIX, you might be in a very good position because it has a steep learning curve. And if you are coming to the game later on, you might be in a position to actually lag a bit around that. I will talk about this concept a little bit later when it comes to the NixOs as a topic. First part of the NIX talk is NIX special language. So first thing what NIX is a language. This is a quote. NIX is a special language, and it is a simple, untyped, purely functional language. It's not a general purpose language as such. Its only purpose is to describe component compositions. A component is created through the derivation primitive operation, which accepts all information necessary to build the component. This includes dependencies, which are other derivation or sources. It looks a little bit strange when you read it the first time, especially if you're not coming from a functional programming background. So it might take a little bit accustoming to the terminology being used here. I just wanted to give a practical and exact definition of what NIX expression language is. Now I'll try to do a little bit more of NIX expression analysis of the language. So it's a simple purely functional language. It's lazy evaluated, meaning that each component is taken only if it's being used at that point. Primarily, you can have dozens of lines of code. If they're never basically called, they will not be evaluated as such. So even if you have a large dependency graph, only the portions being actively used will actually be evaluated as such. Functions are first-class values of citizens, so it's exactly like Lambda calculus here. It's nothing new there. You already have experience with that. It's package-oriented, meaning that we are trying to describe what is the requirement to build something. When I'm talking about package, I'm talking about anything that we will shape as a package. It can be literally anything. HTML, Docker image, Kubernetes manifest, Nomad job definition, whatever we want to create, we can package like such. Produce text file or documentation if we choose so, with the NIX as a package manager. So variants are here easily supported, meaning primarily that one of the hard and usually unsolved issues in every operating system and package manager as such is to have the same package with different versions coexisting on the same operating system, meaning that we do not trample over the other version of the same package because we need a newer one. And a number of different approaches was used in the industry to circumvent this. Docker is one of them. The virtual environments are the other. Virtual machines and such are also one of those. So there are different things that are trying to resolve this type of dependency, that you can have on the same system different versions of the packages that are coexisting without having any issue between them. Now, each of them is basically having one issue that is kind of different with NIX, and that is they are introducing some type of origin there. NIX doesn't. It solves everything through tasks. So basically, the same way that in a Git you can simply switch between two revisions. In a NixOs you can also just use and reference different files that is existing in the system without any Docker component required or any daemon running in the background, literally without anything else but the operating system. So it's much more efficient in that sense. Plus, when we talk about NixOs as well, we are doing this resolution on operating system level. We're not even dealing with another components as such. Some general functional programming language, especially with Haskell, which is borrowing a lot of NIX expression language, it helps. If you don't have prior experience with functional programming, basically we have just a longer learning curve in that case. So it helps if you have this type of a background. Now, there is also NIX REPL. So we can do a quick prototyping, we can check things, we can verify that some syntax is correct. This is NIX language at a glance, so we are talking about language. It's kind of easy when you take the basic concepts. I will just do a short overview of language as such. So basic types, integers, float, strings, boolean, paths are a little bit different. They're not usual set of basic types, but since we're dealing with package management, they're here to stay. And also we have null, so definitely nothing new there. Operations are, again, basic math, string operations, boolean handling and everything, so it's kind of just a basic thing as usual. Compound type are lists. They're, since we're talking about functional approach, they're immutable. They can include expressions, and they can be of mixed types as well, so you can have lists with the strings and integers floats in the same list as well. We have sets, keys must be strings, also immutable, also mixed types available, and so on. Then we have expressions. So we mentioned already a quote where it says that NIX is not a general purpose programming language. So anything we evaluate here, we evaluate to a value or function. So basically, if it needs to be evaluated to a specific value at the end. So it's not a control construct like we have in other languages and such. It needs to be evaluated at the end. It always needs to have else branch, so we cannot leave it empty or we need to get it as such. And it is evaluating to an expression. So that's a little bit different because it's not evaluating to an action as such, but to a value. Also, let expression is based there to give us a scope of variables and so on. They can be nested and so on. And with, similar to Python and C++, we are basically just using how to type a number of prefixes to certain variables, so nothing new there. I'm just giving you a brief overview just to have a glance what is happening in NIX programming language, so you don't think it's some dark magic happening here because it's functional and so on. So it's basically easy to learn and grasp. Just the concept around usage of function being similar to lambda calculus, usually has some learning curve to it, but basically it's a simple programming language as such. It has a complex construct inside, but it's a simple one. Also functions, they are anonymous, so they have only single argument, exactly as lambda, but we are simulating multiple arguments with several techniques. Some of them are mentioned here. Example, if we are creating a function half, it will just, it's have a -6, it's the error on the slide, it's x colon and then x divided in 2. So it's called with half 24, it will produce 12 and so on. So this is type of the function call you will see. And if you have multiple arguments, you will just define them as nested functions or as sets, as below. I won't delve into the details of this thing. It's just so you have the basic idea of how this language, because we're talking about language, how it looks, what we are talking about. As a package manager, it can build anything from HTML file to Docker images, really. It's very portable, currently works in Linux and macOS. You can also do a cross-compile here. So basically you can build on one architecture for another. That's kind of a benefit here. Then it builds upon the concepts of the NIX expression language. So anything that is already mentioned there, like the reproducibility, is applicable here as well. But it introduces some new concepts that are not tied to language itself. This is now specific to package management. So first thing is derivation. This is a action that basically takes everything that is needed and required for the build action to complete the build. If it's sources, libraries, toolchains, compilers, whatever is required and needed, it will be defined in derivation. Later on, I will give a short example of derivation. This is just to expose you to a term that we're using in the NIX ecosystem. Then we have a store. NIX store is placed on a system where the NIX store is storing the derivation and the results and components. So basically, it defaults to the NIX/store, and then we have hash, cryptographic hash of the current build, plus the name for a human readable part, so we can understand only seeing the hash usually doesn't provide that level of detail we would require. So basically, we can easily search for the store, we can query the store, we can check the things in the store. Different packages, different versions of the same packages are being stored on different paths because they have different content, they will have a different cryptographic hash, plus the human readable part, which include the version also, will have a different suffix. So basically they are stored in different folders and they cannot jump on each other. The only way that you can get the same thing to be checked against the store, if your derivation results in exactly the same package, in a byte to byte exactly the same package as you're already having in the store. In every other situation, you will have a different hash at the beginning because they will not be byte equivalent. So that's why they are always in different folders. And that part about the store is really important because everything in the package management level revolves around the store. Now, this type of path handling, as mentioned before, is a little bit similar to the concept in what Git does when changing branches and so on. But here, everything that is built and required for the build is in the store. So if you have intertwined different versions of different packages, some of them are referencing the common or the same libraries they are sharing. Some of them are having double set that are different than the one already placed in the system. So in that sense, we are having issues with this space because we're keeping all the versions we require. But we're also sure, and we can check, that everything is completely encapsulated in this NIX store. So everything required for the package to run is there. It's not somewhere else. If you do the derivation build after some time, we will have exactly the same output. So even if you run it in several years, it theoretically should yield the same result as today. Now we also have standard environment because the majority of the packages is using auto tooling. So basically NIX as a package manager already provides a standard environment so you can build out of the box majority of the packages. It comes to play a little bit later when we're talking about the NIX packages as such. We are building literally everything from the source. And source is part of the build system. Now, we don't want to always build everything from source, because some of those things are repeatable and they're already done and they're not critical to the changes of the source we already made. That's why we introduced also binary cache, so that we don't have to build everything from scratch again. Also, we have NIX packages. That's the part about the auto tools and configuration. We have about 80k packages currently in the NIX packages, and it's being expanded daily, so it's one of the larger troves of the packages in a package management system so far. It's very easy to actually use them. Just as a short example, I was having some issue installing on a Mac system some weeks ago, and it was easier to install the NIX package manager and do it from the NIX in 2 commands than to go through the homebrew and everything that is required to actually install all the details there. It was on the M1, so it wasn't really cooperating properly, so it was kind of very fast to install with the NIX. That's just one of the examples where you can use it, but later on with the shells and some other examples, you'll see why the NIX is very convenient to use from the developer's perspective and from the DevOps perspective equal. Basically, whatever we need is already set up. We can take the changes we want and use them as such. And also as advanced part of the, just to have a hint, we can also do remote builds, which comes in very handy when we have colleagues that are cooperating on the same project. So we have a big machine. When we have such a machine, then our whole team can use it as a remote build machine. Plus, when we have a CI/CD pipeline, it's very easy to have a centralized build server that you can fire a request towards that can later direct them to the target machines and so on. So the target machine that are receiving the build don't need to be as capable as the build machine itself. So it's also cost savings and some other aspects are there as well. So we have some advanced concepts that I'm just mentioning here, so you have the idea about what's being happening there. This is a little bit closer look at the NIX store. There is one thing that is of particular interest. Everything we build in the store is immutable. It's read-only. So once we build a package, it's there. Nobody can change it. So it also elegantly solves some issue in security aspects because you cannot change it. You need to actually build new one to go through the full cycle with the NIX to actually get a new derivation of package, new installation with altered versions. In other operating systems, it's much easier to circumvent this part with simply switching part of the operating system. Here, it's not really that easy. Then packages are stored in NIX store. I already mentioned paths, so don't get over there. We can have multiple versions. We have complete dependencies of a particular package that I already mentioned. We have multi-user support out of the box as well. Now, atomic builds here, maybe they do not really sound that much interesting, but they're very important. Because unlike other operating systems, where while you're building, you can basically break any of the libraries. And if you're breaking them, you're ending up with the operating system that doesn't work. With NIX, you cannot have that situation. Why? Because you can always revert back to the previous version. It is immutable. It's already in the system. It's just a question of either restarting if you utterly broke your operating system, or simply switch back to the previous revision if your operating system is misbehaving but NIX is working. So in that case, it's kind of easy not to mess things up. If you lose internet connection during the build process, if you have power shortage during the build process, anything that can endanger the build in NIX is kind of already solved. So basically, atomic builds are very important, especially from the operating system perspective. You can never basically break your operating system. You can make it unfunctional for a certain component, but a simple restart will correct that. So you have very easy fallbacks. Now, the price to pay is garbage collection. So we have a lot of things piling on this. Also, a lot of the internet bandwidth is used in the process, but garbage collection is something that needs to be done because the NIX system tends to run out of this space rather easily. So that's something to keep in mind as well. System configuration can also be in the store. We have profiles, we have system configurations, and so on. So NixOs' operating system is built on NIX Package Manager in the same manner that it stores its own configuration in the store. So that's how the NixOs is built. We have also think of the file, again, the purity of the build. Those things are anything third-party dependencies. They can be literally anything, local time, network access, third-party script, whatever. NIX has a way of calculating cryptographic hashes of those components. So we can direct it to do two things. Either to do unpure build and alert us of changes along the way, or to rebuild completely and say, I was expecting this cryptographic hash to be for this component, it's third party, but I don't get it, so there is something wrong there. Meaning you can check it and you're aware of any downstream change on a package you're dependent upon. So basically, any third party or malicious access that you will get downstream would be revealed in that sense. And that is part of the NIX cryptographic hash math here. So there are some examples. We're not going to come over them just for the sake of the time. So commands for the store, so you can get some of the references and get closures and so on from Derivation. So you can always query the store basically and see what particular package is dependent upon. Now installing is very hard. This is complexity of installing NIX Package Manager. You can see it, it's as simple as URL and that's it. So if you take one thing home, take this line. Try it home. My friends mentioned in the first slide was saying in 2015 on NixCon, he was saying, I was going around and I was just saying to people, NIX, 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 NIX. So try it, give it a try. The only thing you can get is additional piece of software that you like or don't like. But give it a go. This is everything you need to install NIX on either macOS or Linux system. It doesn't work for Windows. yet. There is Dockerized version you can try for Windows systems, but I will say it loudly as well. I'm a little bit cautious about calling operating system Windows machines and so on. So this is for Linux and macOS so far. And this is now example so that you get a better feel of what NIX can do as a package manager. This is a Hello World derivation example, meaning what is on this screen is everything you need, literally everything that you need in order to build a simple Hello World C program. Now, instead of C program, it can be any binary or it can be any HTML or any other, but this is a short example because I'm guessing that everybody is familiar with compiled binaries before. So Hello World is very easy. We don't have anything but literally print Hello World. We need the source, that's the source. We also need build script, which is part of the build phase in the NIX package management process. I didn't go into the details of the NIX package management process because it would definitely go outside of the interval that we're kind of close at, and we still have some slides to cover. So basically, build is doing nothing but exporting a path. Now, since everything that is built in NIX is built in standardized environment, the home variables, including path and everything in the system, is out of it. So NIX makes very sure that nothing pollutes the isolated build environment. If we want something in the build environment, we have to explicitly tell it, use this one. So we're here explicitly telling it, use on a path of these core utils and the GCC because we want to compile the C code. We are then creating the out folder, which will be the result one, and GCC command for building basically Hello World out of the source. So that's all of the build script here. Everything step by step is quite easy to understand. And then we come to NIX. This is the whole thing. What it says, we are importing NIX packages. We are creating a derivation. It has a name. It has a builder. This is the environment we are going to build in. It has the arguments. We are starting the build script. I mean, you're already familiar with this type. If you ever write any manifest of Kubernetes or Docker Compose, whatever, it's very similar to that. So basically, it's a declarative approach to what we're going to do. And we are inheriting GCC and core utils. We are referencing the path on the builder. We are setting what our source is, in this case, a single file. And we are getting the system to build on a current system because we're not doing a cross-compile. So whatever system you're building in will be included if you're on macOS, if you're building on the Linux system and so on. And then we're building a NIX build. That's it. That's all. That's literally all you need to get a compiled piece of code that will display Hello World when called. So results folder is set there as a symlink stores. So in the current folder where those three files are residing, after typing NIX build, you will get a symlink to the actual store location that will have a compiled version of the script here, of the C source here, and you can run it. If you do results Hello World, you get Hello World on the screen. So this is that easy. The trivial example is such NIX can be very complex in some cases if we want to do very complex things, but same goes for Docker or Kubernetes manifest. They can be very easy and they can be very complex depending on the layers and everything we're trying to, and the abstractions and everything we bring to the picture. Now, NixOs, is it worth it? First, it comes with a nice package manager. I'm guessing that part is a bonus. In a nutshell, it's a reproducible system with versioning, because you can switch back to the previous version very easy. So just some parts from the trenches, I was very cautious to reinstall some of the systems, especially in production environments, and some updates or security updates were always first retried on the sacrificial machines just to make sure that they are properly handled and so on. In case of NIX, even on my home machine, I'm definitely always using just the latest unstable, and if it crashes, it's just a matter of going back to the previous one that is working. So it's kind of very reassuring that it will always work. So reproducible system with versioning is very nice. Declarative configuration, that's very nice. Whoever ever created either virtual machine, Docker environment, Kubernetes manifest, whatever, there is a lot of things we are doing imperatively when we are explaining the step to do something. Here we are having declarative definitions, so we can always put it on a repository, even on a thumb drive. I'm carrying one around, and whenever I want to reinstall something fresh, I just boot NixOs from the thumb drive, apply this very configuration, and I have the same setup I'm carrying with my home setup very easy. Atomic upgrades I already mentioned, so won't get into them again. Those are very fast operation because they are just switching a symlink on the file system. So basically, we are not building anything. We don't have something that will fetch some, image, then start it somehow, have the daemonize process monitoring everything. It's just a symlink switch, basically. So it's kind of very easy and very fast to do so. Now, price is, of course, very liberal in this space. So the first thing I'm suggesting to anybody who is basically building anything on NIX is to take a little bit more than usual than a disk space because it will pile up very fast unless you're doing a proper sanitation and garbage collection. You have a lot of issues with disk space rather fast. So that's kind of a downside of the whole thing. Now, occasional stall rebuild, if we have something that is downstream and requires source rebuild, we don't have it in the binary cache, it will take some time to build. Sometimes some of the things we're doing in production take up to 20-50 minutes to build depending. And it doesn't happen always, it just happens when we need to detect downstream change. Steep learning curve, that's kind of a problematic one, because most people heard that first about the NIX. As you see in the previous example, it's not that complex. Also, compared to complexity of some other system, it's very elegantly solving some issue that we're kind of like having big issues with. So, in the long run, in my opinion, it pays off. Now, this let's quickly change something is habit that most sysadmin that are now Devops are having. Like, let's quickly jump on a system, hide the server, type a few commands, and be done with it. Especially when it's something to quickly fix in the production. NixOs is not so. We actually need to create a derivation, rebuild the system, and so on. So we don't have this quick hack approach, which is for big companies a plus, because you cannot change anything without the process. You cannot just jump on a server and change. I mean, there are ways to circumvent even that, but it's not what NIX is about. If you're doing it in NIX proper environment, you won't do it like let's back on and jump there. You will change the underlying definition of it. So if you need a quick shell to test something, that's additional benefit of it. And this is why I like it. This is the process of when I'm updating my home NIX operating system. I'm having these dot files with the configuration where my flakes are sitting, which are additional layer that is built later on. I just want you to have the idea about the flakes, because if you get into the flakes now, it won't be over for another hour. So this is just the idea of how it's done. I can test it with a build, and I can then switch to it with the next command. I usually don't do a build, I usually do the switch directly, because if it fails, it will fail in the build phase of the switch, but this is just for the sake of showing what is actually being done. This is the whole command necessary to upgrade the full system. It's kind of very easy. Plus, if I break anything, I can always switch back. Now, also part that I very much like about NIX, and I'm advocating to developers to use it as well, are the next 2 points. First is, I want to test something. I have a new package, or I just want to have a graphical version of, I don't know, something that I'm rarely using, something that I just want to use just for the sake of testing it or checking something on the system, but I don't want to leave it on the system indefinitely. I don't want to install it and then remove it. I can spawn a shell like this, take from NIX packages. This is magic wormhole. Again, this was a magic wormhole, basically to create a tunnel for a secure copying of the file to computers directly. And if you are doing it in that manner, you'll get a shell. In a shell, you will get the package that is installed. You can use it. Once you exit the shell, it's gone. Never was on the system. Didn't load anything. Didn't save anything anywhere. That's what I really like about the NIX. Also, if you're doing DRAM integration, as a developer, you can simply switch on one folder. That's very handy for DevOps as well. And you will have the complete toolchain, for example, Rust. Then you're switching to another folder, and you're having completely toolchain that is now set for Python. And then you switch to another folder, and then you're having the complete toolchain for handling a normal cluster or whatever. So basically, changing the folder will execute appropriate NIX commands. You will be having packages that are ephemeral to that folder. While you're inside the folder, they will be active. Once you exit it, they are not polluting the other or completing the other part of the system either. So very convenient for developers. If you're working on several projects and have several Python or whatnot versions, you don't have to do switches with virtual RAMs or whatever. So it's very easy to distinguish those on a system level without really reaching to any third-party tool or whatever. Now, pro and contra. I'll try to make this part relatively short. So managing ephemeral shell environments, very good, very nice. Pure declarative deterministic approach. Package definitions are readable to the extent, of course, you can be cloud if not used correctly. It's easy to debug the build of the package. That's kind of a big plus, because if you're building something, you can always spawn the shell of the build process and do step-by-step of the build process. So when the source is patched, when it's being compiled. And since it is deterministic, once you pinpoint the issue, you can simply take the starting definition and work from there. So it will, again, properly continue from that point on. It's kind of easier than on some other packaging system when you don't have so much control of every step of the build process, because you can jump in literally in every part of it. NixOs is fully fledged OS built on top of it, and active and very expert community. Since it's kind of involved, in terms of time investment to learn it. People who actually learn it are very knowledgeable about the NIX, and they're usually in the same NIX situation. So they want to share this part of the knowledge. So if you get in touch with them, they're usually very knowledgeable about their stuff. Now, the contra. This can easily turn into the unusable pile of the code if you're not careful. So if you get a lot of abstractions of it, you can have dependencies buried deep within the tree. So it takes quite a while of hopping to the abstractions to get to them. Plus, we have this flake versus overlay approach, the traditional old one and the new one that is applicable with flakes. So people are sometimes intermixing them. So some of the paths are in one way, some are the other. So it also can be hard to understand if you're not really careful about it. Steep learning curve, especially for functional part, it's not a mainstream programming. So unless somebody is having computer science background or very keen interest in functional programming, it's kind of hard to get to that point. Documentation is huge, so it's also hard to navigate because of this historical switch and sometimes maybe too technical in some terms. After several years of writing derivations and stuff, people are kind of implicitly assuming that everybody knows what derivation is, so it's kind of very easy to write a technical document that only a certain amount of people will easily understand, the rest will have to struggle with it. So documentation is rather diverse. Sometimes it's hard to find, let's say, beginners-friendly documentation to start with. They did several attempts at the NixOs to actually circumvent this and to remedy this. One of those is NixPills, very good starting point if you're interested in NIX page management and such. It's actively developed and you have a lot of noise around that. Some feature flags, some features, some commands are outdated or changed or using different capacity renamed and so on. So there is active development noise as well. But we have that everywhere. We have that in Kubernetes as well. Since it's very actively developed, it's kind of in a way pronounced here as well. So it's important to track the channels where people are talking about that. Sometimes library and functionalities are not properly documented, and the only source of truth you're having is source code. So you have to dig into the library to actually check it. Some of those are written in something that we understand or know. Sometimes it's some programming language we're not familiar with or not proficient with. So it's sometimes hard to grasp the full functionality of library. It's very convenient if you have somebody to actually show you concepts or the ideas behind a particular usage. That's why I mentioned the long list in the beginning, because without those people, I would have no idea how the NIX works and how to actually use it in production. Store requires, of course, disk space handling, because you can easily go out of the disk space as well. Now, those are deep dive references. Some of those are allocated. It is this NIX build that I just mentioned, also official on the NixOs site, and I will stop with that. Questions? Anybody is still woken?
Okay, so if I understood, NIX package system is totally parallel to NPM or
exactly.
Any of this. So but is there any chance so we can say, look, I really like this provider and this exact NPM build. No need to rebuild it from scratch. Let's just as is.
Not only that, you can do a source code, you can do binary, you can do anything that you implicitly trust with, and say, okay, I have this set up correctly. I want this to be included into the derivation. NIX will take cryptographic hash of that and expect that one. Now imagine that after a while, NPM switched the component you were using. NIX will be aware of that. In next build, it will take the component you directed NIX derivation tool as the input derivation. It will take it, calculate cryptographic hash, and say, wait a second, I was expecting this hash, got this one. This is different. So in that case, you will be aware the change happened. Now, you have two options there, and you can instruct NIX in different ways. You can say, okay, alert me when that happens and continue on, or break at that point until I give you the new hash. So you have the option to verify what is the malicious change or intended change, why this was changed in the first place. So you can do this part as well. You can do it not only from the perspective of alternate package management. You can take binary as such, download it from, I don't know, S3 or whatever, you have it on a local file system from basically from anywhere, calculate its hash and use it as such. We call those often build artifacts. So when we're building something from the side and expect them in the different inputs, we usually treat them as the artifacts. We have a hash, we have a path from where we have expected. It's relevant how it got there. It can be NPM. We can also instruct NIX to actually use the NPM and such in order to get those files in the correct places where you expect them. But you will have added benefit of being sure that you're getting exactly the same situation where you were building. If you're not getting it, you'll get the error notification as such. So you'll know it's different. So yes, it is different. However, keep in mind that npm, apt, and so on, they're all overwriting files. So if they break along the way, even trying to revert to the previous situation, if you're doing an installing or something, you can have a file that is broken. Internet connection failed while you were downloading the file or whatnot, and it was incomplete. You have a library that is not correct on your system and you're not aware of that. With NIX, you cannot have this situation. So yes, it can coexist, it can use it as the artifact and whatnot, but you're sure that you're getting exactly the same end result build as if this file was included in the same capacity when it was declared.
I believe that Ubuntu OS started some new kind of package management to make it more error prone or error proof. Yeah. I'm not sure, is it compatible or?
Yeah, this is not the only one package manager who tried to solve this very issue. There were several attempts to do, and there is a comparative study of other package managers that are using similar approaches to what NIX is using, but not exactly the same. However, this is the only case where we have the full-fledged operating system built with the same mindset in question and residing on the package manager itself. So everything that is done in NixOs is done through the NIX package manager, through the NIX expression language. So we don't have any extra to it. While on the other things, we're usually having extra components that are trying to circumvent or solve a particular part of the issue. In the NixOs, you cannot have a configuration change that is semi-done. It's either done or not. It's similar to the transaction database. It's either fully done or not done at all. You cannot have a half of transaction done. It's in that sense. But yes, there are other attempts as well. However, this is the only one I would recommend for a productional setup in this case. Others are not only well tested, there are very long and involved scientific research that was going into making sure that we have mathematical proof that this is the case with NIX. In other cases, it's kind of an attempt, and let's see that we're doing some of those. But here we have literally proof that this is the case. This reproductive hash will result in the end result that is byte exact of the packages when being built later on, for example.
Maybe you have some big companies which are famous for adopting this.
For example, one of the largest I know that they're using the NIX very much is definitely IOG. So they're basically dealing in the blockchain technology. So they're purely on the NIX. Not only NIX, but they're also purely a functional model, like everything is Haskell or Rust. So it's kind of very same mindset in the deployment. What I didn't mention here is the latest part, which was NixOps as well, because we have a deployment part of the NIX as well, so the ways of deploying NIX packages on the remote machines and so on. So it's also part of the concept, but simply time didn't offer the full review of everything that NIX has to offer. It's a very deep topic. I just wanted to give you the idea that it's easy to install, easy to start with. Just a short example. I was using virtual machines forever, and then Docker came and I was like, bloody hell, this started almost immediately. Like, I just typed Docker and something and look, I got it there. I didn't have to wait for the full operating system to boot and whatnot. It was instantaneous. Compared to the virtual machine, it was very fast. Then I was like, when Kubernetes started to handle Docker properly and everything, it was like, bloody hell, I could spin up like 20 machines in like 3 minutes and they will all tick all together with services connected and whatnot. Persistent volume ticking happily. And it was like, and this is amazing. When I first saw it, it was mind blowing at that point, each of those component technologies. Now with the NixOs, I had the same type of a feeling when I first started to use. I'm not a distribution hopper. Like, I started from Slackware and so on. It was kind of a man of and everything, more or less. But I stuck to some of the distributions, and I was kind of lazy to switch after a while, like old habits that die hard and stuff. When I started using NIX in the production, after half a month, all my home computers were NIX. It's that good. So that's my experience. Your mileage might vary and everything. But I would strongly suggest, like, give NIX a try, see how it goes, because if you're having any interest in having dependable build, something that is declaratively set, that you're always can count on that it will be exactly the same as you wanted it to be. Give it a try. It is a little bit hard to navigate at the start. Maybe even feels a little bit awkward because you cannot do, I don't know, some file in that folder and then you're good to go and stuff like that. You cannot do some ad hoc changes that easy. But when you do changes, you know exactly what you're doing. So for the big systems, for a large amount of servers and everything, this can be a really lifesaver. That's my experience.
Thank you.
Okay.